This beautiful dark object is called Sedna. This is a dwarf planet farther away than Pluto on the outskirts of our solar system, and this object has become the reason for a new controversy or a new theory called Planet 9. What is Planet 9? Well, the theory here says that it's a very large planet somewhere on the outskirts of our solar system, farther away than any other planet known, and here we're talking about distances of about 600 astronomical units. So somewhere over here, somewhere really far away from the sun, and just for a comparison, Neptune is actually right there, tiny object right there. So the reason for this theory is because if you actually look at Sedna's orbit, and I'm going to show you this to you in a second, its orbit is very elliptical, and so Sedna is the reason why we have this theory, and today we're going to talk about the possibility of this theory being true, but also one alternative theory that I'm going to demonstrate using Universe Sandbox 2. Welcome to What the Math. So this so-called ninth planet has actually a term that has been used before. Actually, Pluto used to be known as the ninth planet. Then it lost that because of another dwarf planet called Ares. Where are you, Ares? Let me find you. There you are. So Ares is another dwarf planet that is the reason why Pluto lost its planet status, because once we found Ares, we realized there's actually quite a lot of these dwarf planets past planet Neptune, and they're actually altogether known as TransNeptunian objects, and this is actually just very few of them. I'm going to show you how many there are by showing you another simulation in the Universe Sandbox 2 called Solar System All Possible Dwarf Planets. Now, this is actually not all possible dwarf planets, because we found many more since they've created the simulation, or not many more, but some more, but just watch how many there are that we have in the game. It is ridiculous. So, Neptune, which is right here, is the last large planet, and then right after Neptune, look at all these orbits. My computer can't even handle the amount of TransNeptunian objects. And Pluto is in this ring right here, which is why it's no longer considered to be a planet and just one of these so-called Plutonoids or dwarf planets or very large asteroids. And just to give you an even better view, I'm going to enable orbits, slow down my computer dramatically, and here we go. There's a really large ring past Neptune where you get to see all of these TransNeptunian objects all together. So alright, so that's cool. That's really interesting, but this is not the point of this video. The point of this video is to actually look past that and realize that if I actually enable this again, you'll notice that some of them have a really funky orbit. Some of them actually have an orbit that's very elliptical, very stretched out, and is kind of unusual in a sense. If I zoom out even more, you'll notice there's actually quite a lot of them. Some of them we actually haven't found yet. There's a lot more out there that we haven't found yet. But some, like these two, and also this one here, caused scientists to actually think that maybe there's something else going on here. Now I'm going to switch to another simulation that's a little bit more manageable. This one right here called Solar System, Non-Moons, everything that's more than 200 kilometers. This one my computer can kind of handle a little bit better because it doesn't have all of the dwarf planets, but it does have enough for me to show you what's going on here. So Sedna is right here. Let's just enable orbits again. Sedna is right here, Ares is right here, and look, there's actually at least one more that has a name 2012 2VP113. This is actually because it was found in 2012, and we never really bothered to come up with a name. Actually, there was a name, but the people didn't like it. It has no official name yet, but it also has a very elliptical orbit, and it's actually its periapsis, or its closest approach, is far enough from Neptune or from anything else for it to be influenced by anything else. So for some unknown reason, something may have actually pulled it out into the outer solar system. So in other words, something must have happened to it that its apoapsis, its farthest part of the orbit, has been stretched. In other words, what I'm saying is, for an object to increase its ellipticity like this, without really approaching too close to the other objects in the solar system, something had to actually pull it. Something that is over here had to pull its apoapsis. And in one of the previous videos, I talked about another theory called the Nemesis Theory, where people used to think that maybe, just maybe, there is a brown dwarf somewhere on the outskirts, somewhere relatively far away, possibly pretty far away actually, called Nemesis. And And this Nemesis would explain why some of these objects and some of the comets have such a unique orbit. So here's Nemesis right there. This is a brown dwarf. But unfortunately, this theory has been misproven, or actually proven wrong, because a few years ago there was a very, very, very large infrared analysis of the entire sky around Earth. In other words, there was a telescope that used the infrared emissions from really, really dark objects to see if there was anything large enough for us to discover in the outskirts of our solar system within about 0.4 light years away from our sun. So this analysis, called WISE, determined that within about 0.5 light years away from the sun, there was nothing, no other gas giants, no other large but dark stars, and specifically brown dwarfs, and we haven't really found this so-called Nemesis. So Nemesis theory was unfortunately proven wrong. And so Sedna's orbit, and also the orbit of these other unnamed dwarf planets, has still been unexplained. We still don't know why it's so elliptical. But in 2014, there was actually a publication in one of the astronomical magazines that tried to hypothesize that, well, okay, so there's no gas giants, there's no brown dwarfs, but maybe there is a very, very large planet, slightly smaller than Neptune and Uranus, but larger than Earth, and these are actually, they have a name, they're called super Earths. So a planet that's more massive than Earth but less massive than Uranus and Neptune, that was a little bit closer to the sun. And here we're talking about a distance of about 600 astronomical units. So let's actually, we're gonna take Earth and place it at a distance of 600 AU and give it, let's just give it more mass. Or actually, let's not use Earth. We're gonna use a completely random terrestrial planet. We're going to name it Planet 9. And some people actually suggested the name Nox, so it may, if we actually find it one day, it may have a name Nox. And here, the actual mass of this planet would be about 10 times the mass of Earth, with slightly similar composition to Earth, and its radius would be about 2 to 4 times larger than Earth. It also would have a slightly different inclination of about 20 to 30 degrees, meaning that it's not exactly in the right plane as the other planets. It would actually have a slightly different inclination, and this would of course explain why certain orbits of certain dwarf planets have such a unique eccentricity and shape. And it would also probably have its own eccentricity as well, meaning that it doesn't actually have a very circular orbit. It very likely has a very elliptical orbit. Alright, so orbit-wise, this looks pretty good. Now let's go back here, and we're going to change its composition and everything else that would make it more realistic. So it most likely is not really a rocky planet. It's very likely to be an ice giant similar to Neptune and Uranus. So we're going to give it a lot more, I guess, water, and it may also have things like carbon dioxide and a lot of other ices like methane, similar to both Neptune and Uranus. So in other words, in terms of composition, it would be smaller than Uranus and Neptune, but would have very similar composition. And all of this is actually according to Mike Brown, or also known as Dr. Brown, who actually he's known as the Pluto killer. Yeah, he is the person who found Eris. So we're talking about a person that actually knows what he's talking about, and he discovered Eris back in the day, and he was the person who basically demoted Pluto from its planet status. And so some people obviously don't really like that guy, but nevertheless, doesn't change the fact that he actually is the one person that is now suggesting that this is what this planet would be like. And interestingly, this same person originally was trying to disprove the theory. He actually used the computer simulation to try to disprove this 2014 proposal for Planet 9. But during his simulation, what the computer discovered is that there's only like 0.0007% chance that it is not true. In other words, for these orbits to have an elliptical shape as they do, there has to be some sort of an object somewhere on the outskirts to cause that. And so because of this simulation, Dr. Brown actually changed his perspective and now believes that there might be actually Planet 9. And he even said that he was like 90% sure that it was somewhere out there. Okay, we haven't actually made this gas giant enough, so let's actually turn this a little bit more gas gianty by giving it just a little bit of hydrogen, and here we go. So this is what Planet 9 might look like. It is kind of beautiful, but you can't really see it because it's really, really dark. And the name Nox is the proposed name. As of now, I believe it's a goddess of night and shadow in the Roman belief system or Roman pantheon of gods. And this would be actually a pretty good name because, you know, this is a planet that would be in complete darkness, in the shadow, and it does have a lot of effect on other objects, so just like a goddess does. And if this planet does exist, there's actually already an explanation for how it was formed. So similar to Neptune and similar to Uranus, it may have been formed early on, very, very close to Saturn and Jupiter, so somewhere closer, because these two, Neptune and here, I'm just going to disable this for a second. Neptune and Uranus, they were formed a lot closer here. They were actually in the inner solar system until something kicked them out to the outskirts, and we still don't know what that was. And they started orbiting farther away from where they were formed. Now, it's very possible that there was another gas giant, or in this case, this would be called an ice giant, that was formed and also got kicked out even farther away. And maybe, just maybe, this is actually what Planet 9 is. And its orbit around the sun would take it about 20,000 years to complete. And so every 20,000 years, it may actually have some sort of a hidden effect on the objects in the outer solar system. Specifically, we're talking about different comets, different asteroids that are orbiting here on the outskirts. And maybe because of this, this would actually cause more of these objects to approach the inner solar system and possibly even crash on Earth. So in other words, this would maybe explain some of the theories behind the repetitive extinction events on Earth every once in a while. But what about that WISE thing that I was talking about, also known as the Wide Field Infrared Survey Explorer, that in 2009 showed that there was no Nemesis? Well, the thing is, WISE didn't really look for objects that were smaller than Neptune and Uranus. And if this planet is out there, it would be smaller than them. And it's very likely that we just, you know, haven't found it because we weren't looking for smaller planets. And as soon as the announcement about Planet 9 was made by the astronomical community, and specifically we're talking about January 2016, interestingly, one of the telescopes known as Subaru telescope in Hawaii started to look for it. He actually, not he, but the telescope and the scientists behind it started to actively search for this hidden object, hoping to be the first to discover it. And in the next 5 years, this is where the exciting time for the astronomical community is, because in the next 5 years, we may actually cover this whole area of the sky and possibly find it or find nothing. Now, one question you may be asking yourself is, well, how does this, or can this planet affect Earth as well? And the answer to this is, well, no, it's too far away from the sun. If it's out there, it would not affect Earth at all, in the same way that neither does Uranus or Neptune. They don't really affect Earth as much as Jupiter. And this planet, as a matter of fact, if it is out there, would not really affect anything within about 150 astronomical units of the sun. So within about a distance of this much, so a distance that is farther away than Pluto, and nothing would be affected by its gravity. But objects that are farther away, so objects like Sedna and a few other dwarf planets, would actually be affected by it, and this is why their orbit has possibly changed so dramatically. Alright, well, so we've talked a little bit about the possibility of Planet 9 being out there. Let's talk about the impossibility now. We're going to talk about some ideas here that may actually disprove this and possibly explain the orbit of Sedna in some other way. Well, firstly, back in 1999, there actually was another proposal about another planet. It was actually called Taiki. This was a hypothetical gas giant in the outer solar system that was proposed by, I believe it was a team from the University of Louisiana at Lafayette. And they were trying to explain away the elliptical orbits of certain comets. This was before Sedna and Ares were discovered. And back then, we didn't really know there were so many dwarf planets on the outskirts. And so they were trying to explain why some comets have such an elliptical orbit. And here's Taiki, just for fun, it's orbiting around the sun as well. And so today we actually, because of the survey that tried to find these large gas giants, today we actually believe that Taiki is most likely not there, and it's very likely that it doesn't exist. As a matter of fact, it was a hypothesis that has been sort of proven wrong, and so unfortunately, after the WISE survey, we know that this most likely doesn't exist. So I guess what I'm trying to say is that Planet 9 is actually not the first time that something like this was hypothesized by the big scientific names, because Taiki was also hypothesized by actual astrophysicists. But what I really wanted to do is actually offer you one alternative hypothesis. And here we're actually going to do this by, well, I'm going to show you the orbits here and just look at the inner rings here. So we're going to be looking at all of these other inner objects, including objects like Pluto and a lot of other unnamed or badly named objects that never really got to have a cool name like Sedna or Ares. They just have number classifications. So what we're going to do now is we're going to just propose one alternative hypothesis, and specifically here, a hypothesis that, I mean, kind of makes sense. You know, maybe, just maybe, one day, a long time ago, there was a very large object, possibly a brown dwarf, that passed within the outer solar system that actually has shifted these orbits to this particular shape. And if, in other words, something may have passed, but not really stayed in the solar system. So maybe it passed and left, and this is why we haven't found it yet, because it's just not there anymore. It just left, it disappeared. And so what we're going to do is, I'm going to launch my favorite brown dwarf in the game, which is called, you probably know this already, it's called Wolf 359. It is technically called a red main sequence dwarf, but I just call it brown dwarf because it's technically a brown dwarf. Anyway, so we're going to launch it in, I guess, maybe at a speed of about 15 kilometers per second. It would probably be moving faster than that, but let's just say 15 because we want to see it in slow motion. And it's going to pass maybe this way, and or actually maybe this way. And let's see what happens to these inner orbits. Let's see if anything happens to them. So I'm gonna place myself here. We're going to aim this direction, and let's just launch it. Now let's see what happens. If nothing happens, then, you know, maybe Planet 9 is out there. If something happens that doesn't really look realistic, then maybe Planet 9 is out there. But if something happens that does create these elliptical funny shapes, then maybe, just maybe, this is actually what happened. Now I'm gonna, maybe let's just name it something cooler though. Let's name it, well, let's name it Nemesis. I kind of like this name so much that I'm gonna call it Nemesis. Nemesis the brown dwarf is back. And so we're watching, and look at that. First orbit already started changing. We're just watching these inner circular orbits. And everything that you'll see changing here are the orbits of different dwarf planets, different planetoids and plutoids that are also known as TransNeptunian objects. Now, let's accelerate this a little bit. Right now, we're at months per second. We're going to go at almost a year per second. Or actually, this is good enough. It's moving fast enough. And I totally realized I misspelled Nemesis. I need to fix this before we continue. There we go. All right, so here we go. Here comes Nemesis. And I should probably zoom in on the sun because we're watching the orbits in the center here. And notice how many orbits have already started changing, and they started becoming more elliptical, more withdrawn, or more drawn out, that is. And so as Nemesis, which is right here in the middle, kind of hard to see. Look at that. See how elliptical this has become? And this is what Sedna's elliptical orbit looks like, actually. Now, this is actually possibly a little bit too close to the sun. I shouldn't have put it so close because this will also affect the orbits of planets now. I believe Neptune and Uranus might get affected by this. But what's really important to see here is that a lot of these other dwarf planets started to change their actual orbital shapes to look something similar to what Sedna has right now. I'm gonna just accelerate this a little bit just so you can see the final effects. And look at that. See how they are all changing now? Many of them becoming either less elliptical or more elliptical, or even escaping into our solar system. And this is essentially what could have happened. This is another possibility. Maybe a brown dwarf or something relatively massive passed within, within a relative distance of our solar system, and just changed these orbits to look in that way. Well, okay, so a lot of orbits obviously change, but let's try this. I want to try this again, but this time what I'm going to do is I'm going to remove all of these other highly elliptical objects like Sedna. We're going to remove Ares. We're going to remove this right here, and just leave the dwarf planets that have a relatively circular orbit, or more or less circular. Oh, no, I missed one. Here we go. This was the last one. All right, so this is relatively circular. I'm gonna leave the other ones. They're not too elliptical. So what we're gonna do is we're gonna launch it again a little bit farther away and see what happens to these objects right here. So this time we're gonna launch it a little bit further, and let's rename it again. And so you can see the Nemesis path is a little bit farther out now. And let's just see what happens to these circular orbits, or relatively circular orbits, if they become more elliptical. So we're going to accelerate this one more time and just watch the orbital path. And after this first passage, this is what happened. So some of the orbits became more elliptical, and, well, to be honest, not enough for me to actually be proud of what I just achieved. So I'm going to try this one more time, but this time launch it just a little bit closer. This was actually about 150-ish astronomical units away. We're going to launch it just a little bit closer and see what happens again. So this time, let's launch it just around here, just past orbit of Pluto, maybe at a distance of about 80 to 90 astronomical units. So let's see what happens this time. You see that it's actually basically passing through the orbits of these dwarf planets, and let's see what happens to their orbital paths and their orbital shapes. So here comes the first one, becoming more elliptical. Here comes another one, and all right. So okay. And so this is the after effect of the second passage here, and you'll notice that many of these orbits have now become a lot more elliptical than before. As a matter of fact, some of these objects have moved farther away than they used to be, which would actually kind of explain why Sedna is so far away and has such an elliptical orbit. Now, this may not explain everything, but it would definitely offer another alternative explanation to why Sedna and other dwarf planets that don't really have cool names yet have such a strange elliptical shape, such a strange elliptical orbit, and basically why they are so far away from us. And I guess one explanation here is that maybe sometime a long time ago there was something that passed by close enough to us that changed their orbit. Now, if you can think of any other really cool hypothesis or explanation for why Sedna's orbit and some of the other orbits are so funky looking, do post it in the comment box below, and we'll maybe talk about it in one of the future videos. But I actually think this is a pretty awesome time in the astronomical community, because now we'll be very excited. A lot of people will be looking for this hidden Planet 9. A lot of people will try to actually discover it. And I personally will definitely be rooting for them to discover it. I'm not going to be the person trying to disprove the theories. I just wanted to offer you another possible explanation, because I personally think maybe there is actually something out there, and hopefully we'll actually one day even land on it. Anyway, so this is all I wanted to say in this video. Hopefully you enjoyed this video using Universe Sandbox 2. And if you have any other comments, please post them in the comment box below, and I'll get back to you as soon as I can. And if you did enjoy this video, check out some of the other Universe Sandbox 2 or any other astronomical videos I posted previously, and do subscribe to this channel if you still haven't. Also, don't forget to like this video and share it with people that you think would like space, universe, galaxies, and other astronomical, mathematical, and scientific stuff. And anyway, thank you so much for watching, and as always, game you later, see you in the next video, and bye bye.